So as we continue into statistics, one of the big topics you'll come across is what's called measures of central tendency. So there's mainly three that we deal with central tendencies, and those central tendencies kind of applies to this middle. So we kind of see here that the measures of central tendency are statistical values that describe the center or typical value of a data set. So kind of a typical value kind of means, average, if you will. So kind of there in the middle, if you will, kind of average. So these tendencies help us summarize large amounts of data with a single representative number. So when we have large amount of data, a lot of times we'll base things on the middle. So the main three measures we have is what's called the mean or arithmetic average, if you will. So to calculate the mean, what you do is simply add all the values together and divide by the number of values that are present. So it's best used when the data is what we call symmetrical, no extreme outliers. A lot of times this symmetrical word, we'll be using a word called normal distribution quite a bit, which will kind of represent the symmetry. So symmetry is very powerful when it comes to the arithmetic mean. Now, if there's extreme outliers, that can really impact the mean quite a bit. So it's affected by a number that is really far off from the rest of the numbers. So a formula we may come across is the mean is equal to, and this is in our book. This is the summation symbol. So this says sum the values together and then divided by n stands for the number of actual data values. Where the mean is basically, where x is a data point, x1, x2 through xn, if you will. So a lot of times this notation here, x bar is going to stand for the sample mean, if you will. So this is going to stand, so x bar is our sample mean. So it's the same thing as our x bar, if you will. So that's going to be an arithmetic mean or an average. And again, x bar, if you will, the sample mean is going to be the sum of the x's divided by the number of values there. We'll look at an example here in a little bit. So the median, the challenging about the median is the data has to be arranged from smallest to largest first. So the data has got to be ordered. And then what we do is we identify the middle value. If there's an even number of values in the middle, you have to add the two middle values together and average them. So add the two middle values and divide by two. That'll average the two middle values. If there's an odd number of values, there will be a middle value. So the median really helps us when we have skewed data. So if there's outliers, if you will, because you can start to see the clustering with the median. It's like the stem and leaf plot. Notice how the stem and leaf plot was kind of an organizer. That's really great for the median. So the advantage of the mean is you don't have to order them, but for the median, you have to order the data. The mode basically is the value that appears most frequently in the data set. So the data set could not have a mode. It could have one mode or it could have multiple modes. So sometimes we may see where it makes sense is like bimodal, two modes. So usually the mode is when there's a most common category. So for me, what's the most common food that people like? I think at the community college, they kind of focus thing on what people liked, and they try to put that on the menu because they want to kind of sell that product. So it's kind of where you're talking about a most common category. It really helps out a lot in that sense, especially in purchasing things. So when looking at the mean, the median, and the mode, The mean is going to be best for symmetrical numerical data. So there's symmetry in it. But it is very sensitive to an outlier. The median is very good if there's a skewed distribution. So like I said, the stem and leaf plot can really, so we kind of pick up on that frequency, if you will, those distributions, if you will. And mode also kind of focuses on that frequency. It's the most common value. So it really comes in handy there. So if I look at this first example, we have, let's see here, we have one, two, three, four, five values. So if I want to find the mean, I have to add all these numbers together. So if you will, this X bar is going to be this 5 plus this 8 plus 12 plus 17 plus this 19. And then you're going to divide it by, let's see here, I have the uh, pencil is kind of acting weird here, kind of freezes. Let's see what we got going on here. So we had one, two, three, four, five pieces of data. So we're going to divide that by five. So if we do that math, we can do it by hand or with a calculator. These numbers don't look that crazy here. I can kind of see 8 plus 12 is 20. So I've got those. 5 plus 17 is 22. And then we have this 19 divided by 5. And then we have 42 plus 19. Divide that by 5. So that would be what, 61? So 61 divided by 5. So if I go 5 into 61, we know 5 does go into 6 one time. 1 times 5 is 5. With the remainder of 1. Bring 1 down. 5 goes 11 twice. That would be 10 with the remainder of 1. And I can add a decimal and add a 0, bring 0 down. 5 goes to 10 twice. So we would say 12.2 was the median. Now, to do the median, I'm sorry, 12.2 would be the mean. So X bar would be 12.2 if well, I didn't have to round it because it turned out evenly there. Just pay attention to rounding if they want you to actually round it further than that. Usually we want to go one more place than the data, but I don't think our book actually does that all the time. So the median, we order the data, so it looks like it's already ordered. So the 5, the 8, the 12, the 17, and the 19. And since there's five pieces of that data, notice that the middle value, this 12 is jumps right out at us. So the median would just be this 12. Now notice there is no common number. There's no great repeating number anywhere. So all the numbers just repeat once. So since all the numbers just repeat once, we would say this does not have a mode. So I'm going to pause this as well, and I'm going to show you how we can also do this using Excel. So we'll do this same example, well, a different example using Excel.